See my screen. Hello, everyone. My name is Danielle Sandella. I'm from Langen Engineering. I have been doing wastewater work for, a pretty long time. Been really focused on wastewater compliance for about 10 years, but all other things multimedia, EH&S. And see if I can figure out how to work my screen. Maybe that's not my area of expertise, clearly. Um, yeah, I have been, spent a lot of my career supporting industrial facilities, facilitate wastewater permitting, help them, manage their treatment systems, apply for permits. I've been involved in several significant non-compliance issues, consent orders, and have really helped, our industrial clients make their way through the regulatory chaos, as it were. I work with people to really make sure that you guys can continue making what you make and doing it in a compliant manner. So today, we're going to talk about wastewater permitting. And as I was putting this together, I was really thinking about, what is really important for, the manufacturers to know about wastewater permitting. I could go on and on and on about the regulations themselves, but when really taking a step back, I thought, how this thing comes together, how you identify your processes, and how you really understand what's happening in your own facility is the number one biggest hurdle of figuring out which permit that you do need, or if you need one at all. So I've definitely put a focus on that for this session. So today what we're going to cover, we'll do an intro to wastewater. So a really brief overview of the regulations, go through the definition of what is industrial wastewater, talking about some things that are common, and then a bunch of commonly overlooked sources. We'll go through a water balance. What is the water balance? How do you make a water balance? And the importance of the water balance. Understanding your processes, developing process flow diagrams, and recognizing if you have applicability to the categorical pretreatment standards. And then we'll talk about selecting your permit. We'll do a quick overview on wastewater treatment systems and how the Clean Water Act permit will also allow you exemptions under RCRA permitting. And then also a little brief description about violations, common violations, why they happen, and what to do if it does happen. Okay. I'd also, if anybody has questions or anything as we go along, please feel free to come off mute, ask your questions, or type them into the chat. I'd be more than happy to address things as you go. Sometimes, you think of something and then you forget by the time it's over. So please jump in, ask your questions. Let's have it, be a discussion. Okay, so Clean Water Act, this is the basis of the whole thing, right? Clean Water Act was established, and it establishes the NPDES program, National Pollution Discharge Elimination System. So this is the program that facilitates you getting a permit. It requires you to have one, and it creates the structure that for which you can apply and obtain one. So the program covers both indirect and direct dischargers. So direct discharger meaning right to a surface water from your facility, and indirect meaning that it comes from your facility to a POTW, to your municipal plant, and that plant then further treats it and sends it out under their NPDES. So the program can be facilitated either through a general permit or an individual permit. So an individual permit will be issued to you, to your facility, to your process. And they're generally more tailored to what you have on site. So there's a little more flexibility in being able to drop parameters, or, it's tailored to you. That being said, it's a little more complicated, a little more onerous to obtain. A general permit is issued just generally to the public. and it allows anyone who falls within the definition of what that general permit is to be covered under that general permit. So sometimes the general permits are, what we would consider a permit by rule, where it just exists, and if you meet the definitions, you're covered by it. Sometimes they're specific and they require authorization, a notice of intent for coverage or registration under that permit. But generally speaking, the general permit process is a little more streamlined than doing an individual permit. That said, there's a lot of terms in the general permit because it's meant to apply to the widest variety of users possible. So, there could be things that, may not apply to you in that permit, which is fine. In some cases, there's requirements to sample in those permits for things that maybe you just don't have. So there's pros and cons to both processes, and we'll kind of touch on that as we go through the process. So the NIPDES program is generally delegated to the states. So this is a map right here that basically says, depending on what state you're in, obviously, I think most of you here are in Florida. Florida is fully authorized to implement their program. So when you go to get your permit, you're doing it through the state of Florida as opposed to doing it through your regional EPA. Likewise, POTWs may be given the authorization over their own pretreatment programs. So if you're intending to discharge to a POTW rather than directly to surface water, the POTW will be the person that actually issues the permit according to their pretreatment program. So the big question, what is industrial wastewater? So industrial wastewater is pretty much everything that's not domestic sanitary water. So if you wouldn't have generated it in your house, then it's industrial wastewater. Primary types of wastewater are processed wastewaters that are really specifically from a manufacturing process. These types of waters, they come into contact with contaminants, with raw materials. They're needed to facilitate the manufacture of the widget. And then there's wastewaters from industrial support equipment. So things like boiler blowdown, compressor condensate, cooling towers, all the things that make your facility run. Those are also industrial wastewater. And then we get into the more elusive sources. So this is a comprehensive list of some of the commonly overlooked sources of wastewater within facilities, and it's pretty long. So a lot of these items too, you'll notice, like air compressor condensate, right? I mean, it generates so little usually. It's one of those things that you just kind of forget about because it's not a major source. Backflow preventer test water. When was the last time anybody thought about their backflow preventer? So things like that are generated from the industrial process or the support, but are just commonly not thought about. So boiler blowdown is on here. Building maintenance wastewater is a really interesting one. This one is essentially, most commonly anyway, mop water, right? You have a process area, you're manufacturing things, and the floors are cleaned. Though that wash water will carry the same or similar characteristics as whatever it is that you're making in most cases. So this is another commonly overlooked item because it's just mop water, right? But it's very similar to processed water in some cases, and it should be considered an industrial source. We have contact cooling and heating. There's the cooling tower blowdown maintenance, cutting and grinding, goes on and on and on. Laboratory wastewater is another really, really commonly overlooked source, particularly when it's in conjunction with any non-destruct testing. There's always a lab sink in an NDT area that everyone forgets about. So those are also sources of industrial wastewater that would need to be included in a permit. Photo processing, pump seal, condensates. Vehicle servicing and washing, that's another elusive one. If you are doing any servicing or washing of your vehicles on site, that would be considered an industrial source as well. And then the last very elusive one, water treatment wastewater. So if you have softeners, you have RO rejects. So those backwash or reject water is considered water treatment wastewater, and those are also considered an industrial source. So we have the processed wastewater, we have what I like to call the drips and drabs of wastewater, all the support equipment stuff. Collectively, industrial wastewater, one of the things that you want to evaluate as you go along is if you meet the definition of a significant industrial user. So an SIU, as they're known, is anyone who's applicable to categorical pretreatment standards, which we'll talk about in detail a little later, or an industrial user that generates a lot of water. So generally speaking, over that 25,000 gallons a day, or that comprises a significant portion of the capacity of the receiving POTW. So a lot of stuff I just threw out. So, okay, where do I start? That's great. There's regulations, there's definitions. So what does it actually mean? So the first thing we want to do is create a water balance. So some facilities, this is a corporate requirement, and you have a really good idea. And other places, if you don't currently have a permit or it's not a corporate requirement, maybe you don't have that great of an understanding of every drip and drab, everything that comes through. So the good water balance is the basis for everything. That is it. Your entire permit gets constructed from there. So when I'm walking into a facility to support, an application process, or even just an evaluation, the very first question I'm going to ask is, can I see your water balance? The water balance will tell us pretty much everything. So it allows a facility to really understand what your water use is. Ooh, we have a question.
Yeah, you keep using the words water balance. Is that like a measurement of flow? Is that defined?
Absolutely. That'll be our next slide. So with that in mind, I'm going to skip ahead and then I'll come back. So this is a quick overview of exactly what a water balance would look like. This is a real one for a manufacturing facility in the Northeast. This facility uses about 500,000 gallons a day, so big facility. So tracking every drip and drab of water use, it was a project. It was certainly a project. So this is essentially what a water balance will look like. It is a calculation of what it comes in, what's coming in, how it's being used and where it's being used, how much you're losing in evaporation, if there's any treatment happening along the way, and where it's going to end up going. So it's the entire thing beginning to end. See if I can go back. So that tells us pretty much everything, not everything, most of the things we need to know to determine where you fit in terms of a permit. So as you're going through this process, what happens is you discover things, right? You discover things that are using water that you didn't know about. You discover leaks. One of my favorite stories is we were doing a water balance for a facility, and we found out that their water meter wasn't working properly, and they had been, not charged properly over the course of years. Another case, we figured out that the facility and the POTW and ultimately who they were paying, the sewer department, had not accounted for significant evaporative losses, and they were paying to discharge water that was evaporating rather than being discharged. So through this process, we really gain a great understanding of how water moves. And a lot of times it actually benefits the facility because you find ways to save money or ways to reuse water. And it's also the basis for sustainability metrics. So, for those of us who are starting to really focus on how can I use less and, how much are we even using? This is the basis. So what makes a good water balance? So determining your average and maximum operating conditions, and then selecting a wide time period. So typically we recommend we go back 2 years, and we use real life data, water bills, meters, reject rates, whatever real data we can get on the water. We go back 2 years and analyze any data we can, figure out how it's divvied up throughout the facility, and make it balance on both ends. So these last couple of years have been interesting, in terms of, doing these processes, doing the water balance and really analyzing the process. Nothing has been normal in the last 2 years. So for those of you who are looking forward to doing renewals or maybe permitting for the first time, we'll probably have to go back further or make some different estimates. It's going to be an interesting time because with COVID, places shut down, production changed. In some cases, production went way up. That's way outside of normal. For some places, it went way down. So understanding how your business impacts, the water balance is also really important. And then, of course, my note here on the bottom, meters, meters, meters. You can never have too many. The more meters you have in your facility, the better a snapshot you'll be able to get of what your real water use is. So we went through this one. So there's that process, beginning to end, water coming in and water going out. And then we'll come back to the drawing. So this is, like I said, a pretty large water using facility. In this case, we had multiple meters in, we had several points of measurement out. We were lucky. And even with this, it was really difficult to figure out where water was being lost, how maybe waste was going out with some water in it. So we had moisture retention. But this process really gives you the overview of where everything is. This is another smaller facility, much simpler process where, there wasn't that much to track. This is maybe, between a little over 4 to 8,500 gallons a day, some cutting water, some anodizing water, that building maintenance water. And in this case, there were, I believe, multiple meters. I think we had multiple points of measurement. So it was actually relatively easy to balance this all out. So those are just a couple examples of complicated balances versus pretty simple balances. Another thing of note is that as we're going through identifying the processes, how much water each of them use, we're also going through and identifying points of reuse. So in this case, there's some recirculation. And then also waste that's hauled offsite versus discharged versus maybe discharged to a separate outfall or monitoring point. In this case, there was 3 different ways this facility discharged. And then there's evaporative losses as well. So water balance takeaways. The water balance becomes the basis for the permit application, and it really supports determining which permit mechanism is going to be appropriate. And it gives you a working document to evaluate your facility. Can I use less water? Can I reuse water somewhere? In one of our, one water balance I worked on, we figured out that this facility had all of this single pass cooling water, and it was a majority of their water use. And it was like, we can drop down to a general permit. We were able to make a bunch of changes just based on closing the loop on single pass cooling water. Does your water balance make sense? Are there losses in the systems? You have pipe leaks. Is there something that's running all the time? And then, can I consolidate my discharge points? So you may find that you can combine like effluents, and we'll talk a little bit more about this in the next section. But can I consolidate like effluents to minimize how many places I might need to sample with my permit? So I see some typing. Does anybody have any questions? Want to jump in on a question so far?
Who normally performs the water balance?
It varies. So some facilities do it themselves. A lot of facilities opt to have a consultant do it. But it is up to the facility or their consultant to prepare the water balance.
So when you say the facility, meaning the EHS manager, the maintenance, the engineering team?
It is a team effort. It is always a team effort. So it usually starts with EHS. And then, you get the water bills, you get your effluent meter readings if you have them. And then once you start drilling down, the in never equals the out, right? It never happens. So then you start hunting for losses. And that's where you start getting involved with, your facilities team and understanding boiler blowdown, right? How many cycles is your cooling tower set for, and how much is it really discharging? So facilities becomes really, really important in this process for the support equipment. And then your production team will also become important, particularly as, if you evaluate reuse or reduction measures as well. They become integral in, contributing to what it is using and how much it could be reduced if you wanted to go that way.
Thank you.
No problem. Anybody else? Okay. Okay, so understanding processes. So process chemistry. So the actual thing you're making, what your facility does. So how is water used in that process? In some facilities, the case is it's primarily, cooling water, cooling towers, like a single pass. And that's pretty much it because the widget itself doesn't require water to be manufactured. In other cases, water could be the basis of the whole thing. I use plating shops and metal finishing operations as an example in everything because that seems to be one of the more, regulated entities in terms of wastewater. So, you can't plate a part without a whole lot of water, a lot of water. So sometimes it's integral to the process and there's no way to avoid significant water use. So understanding your process is really, really important. And this, again, is a place where it's important for the EHS team and the manufacturing teams to come together. I can't count how many times I'm working with a really, really amazing EHS team and we have one understanding and then we're like, we got this, we know what we're doing. And then we sit down with like the process engineers and are like, oh no, that's not at all how this works. It's all the time. And as most of you guys, EHS professionals, you guys probably know, yep, that is what happens. So understanding every bit and piece of your process is critical. So how are things coming into contact? What chemicals are being used? Are contaminants being carried out? Is a part cleaned and it's carrying off oil? Is there maybe residual metals or metal dust once you clean it that's also being carried out in water? Understanding your raw materials used in the process, the reactions and breakdown products. I had a case last year where we had chloroform, couldn't figure out where chloroform was coming from. Well, there's no chloroform in the process. There's no chloroform. Went crazy looking for chloroform, figured out it was reacted in pipe. right? It was created from two different things coming together that it was completely unintentional. So really understanding where things are coming from and what they could make if they're combined. And then evaluating the potential for adverse reactions in effluent piping and treatment systems. Like I said, this case, we made chloroform. In worst cases, if you have cyanide bearing processes, those want to be completely segregated from acid processes, not to make really nasty stuff. So it's important to understand everything you can about what you make and how it's made. So identifying those processes, developing the process flow diagram. This is probably the second most important document that you'll need to both determine what permit you need and then submit as part of your permitting process. So again, picking on plating shops. This, what I'm showing here is essentially a plating line, right? This is the process by which water, a part and water moves through a process. And then we also show how water is reused, countercurrent rinsing, places it's recirculated, places where we might take a primary rinse and use it as makeup to a process. So really understanding how parts, chemistry, and water flow through your process. We also want to identify if there's treatment units integrated within these processes. So in a lot of cases, there's little filters, there may be like particulate filters, or sometimes there's even, more like an ion exchange vessel on the back of these to kind of keep water clean as it's going through. So really understanding every bit of the process and developing this diagram which lays it out. So I'll add a little note here that a lot of times what happens is as we go through this process, we're understanding the process, we come across information that's proprietary to your manufacturing process. So when that happens, it's important to flag that and decide whether it can be generalized or it needs to be submitted as proprietary. So anything that goes into a permit application becomes a matter of the public record. So if you don't want literally anybody to know it, then you want to protect it in your application. So it's always good to have your internal version that may have all of the gory details of how it's made, and then have another version that may get submitted that is a little more generalized so nobody's out there replicating your process. So that brings us to the categorical standards. I mentioned these in the beginning. So what happens is you have a process, and depending on what that process is, it may fall into one of these buckets. If it does fall into one of these buckets, then additional or specific requirements apply to your permit. So you'll recall under the significant industrial user requirement, that definition partially hinged on whether or not you meet one of these definitions. So EPA has essentially gone through and says, if you're doing one of these things, there are particular constituents of concern that we want to regulate, and just universally, we're going to apply limits. Now, specific POTWs or states could lower those limits, but on the federal level, you cannot discharge any more than the limits specified in these standards if your process meets those definitions. You'll notice it's pretty wide covering here. Pretty much anything you can make is could be covered under one of these. So it's one of those cases where unlike a, let's say, a stormwater permit, where it goes by your SIC code to determine applicability, this goes strictly by the process itself, whether it meets the definitions. So I'm going to jump ahead a little bit. So there's three super common ones: metal finishing, pharma, and inorganic chemical manufacturing. In my experience, I've probably come across more of these than anything else, and more metal finishing than all of them. Metal finishing like shows up in places where you wouldn't expect. So in talking about the definitions and things like that. So this is an excerpt out of the metal finishing categorical standard that kind of lays the groundwork for how it applies. So if you are doing one of these 6 primary things: electroplating, electroless plating, anodizing, coating, chemical etching and milling, or printed circuit board manufacture, that's how it's defined. If you're doing these things, this thing applies to you. And P.S., if you're doing these things, these other 40 things that you're probably also doing, all of it becomes categorical wastewater. So things that would be seemingly unrelated now become part of that category and need to be regulated and permitted together. Any questions so far on this? So a couple of important tips for 433. So I suspect at least 1 or 2 people on this call is, thinking, yep, this might be me. So things that are really, really commonly overlooked. You see my picture of this lab sink on the side here. So this is another fun story where a facility became applicable to a categorical standard because they were inspecting parts, and in the process of inspecting the parts, they did a little non-destruct test where you take your cotton swab and dip it in acid and put it on your part and then inspect your part. And it's essentially etching. It becomes an etch process. Now, that wouldn't have been too big a deal, except they also had tumbling, and primarily tumbling, but tumbling and cleaning and all things that wouldn't have applied had this primary process not applied. So this little, this etch process became the catalyst for a much stricter permit than would have otherwise been needed. And then the other interesting tidbit is, of course, the first question was, well, what if we just don't discharge that? Guess what? If you're doing it, the standard applies whether or not the water actually is discharged or goes to a treatment system or otherwise goes down the drain. The presence of the process itself becomes the catalyst for applicability to the categorical standards. Wow, say that 5 times fast. So you don't always have to actually discharge it for the requirements to count. So in this case, in 433, you also have to remember this F006 waste code applies to treated rinse waters. And that waste code applies based on the manner in which the water is generated, not its chemical characteristics. So you can have water that is essentially clean. I have been in facilities where there's water I would actually drink. It was that clean, but it was still considered an F006 waste because of the way it was generated and the way it was treated and, in that case, reused. So these moral of the story is the categorical standards have sneaky things in them. It's really important to understand your process, whether or not your process applies to the standards, and then understanding what the standard really says and how it applies to what you're doing. Oh, and back to the water balance. Did I say that it was the most important thing? So after you have gone through this process, now we know what's using water. We know what we're making and how it's made. So now we're going to go back to our water balance and say, okay, now I'm going to group my things. So what are my inputs, right? Which things are going to be applicable to that categorical standard? Can I group them together and discharge to one treatment system, one sampling point, something like that? and make sure everything is accounted for. Most important thing. So I feel like as you go through the process, you always find things, again, you never knew about your process that then have to go be put back onto water balance. So here's another example, again, another metal finishing facility, but this is a case where we had multiple things going on and we grouped them. So this part in the middle, this was all their metal finishing, right? We know that these processes generate water that applies to that standard, so that's all going to go to the same place and go to the treatment system. We had other stuff in the facility like their RO, didn't count, doesn't need to go in there, can be discharged under a general permit, totally separate, don't need to know about it. And then we had a cooling loop, same thing, cooling water, any makeups, losses, or if they had to clean it out, none of it counted. So that also didn't have to go through their treatment system. It allowed us to size down the system a little bit by not including things that didn't need to be in there. And it also allowed us to streamline their permitting process because we were allowed to use 2 separate general permits for this rather than get an individual permit for the facility. So that brings us here. So how do I know what permit I actually need? So the first 2 steps will really dictate that for you, right? You know how much water you have and you know where it's being generated from. So at this point, you're going to know if you're a categorical industrial user. You're going to know if you're a significant industrial user. And then you'd want to compare those things against the permitting programs that are available in the state. So the easiest one is going to be your permit by rule. That's like if you have something really simple that, you know, is written into the standards, you don't actually have to get an authorization for it. Essentially, nobody cares too much about some condensate somewhere, you know. The next level is going to be a general permit, and general permits will either be to discharge to the sanitary sewer or to discharge to a surface water. Those are a little more work, but still not, you know, too much. And then the individual permit level, again, that's the most involved in applying for it. But sometimes there's advantages to having them. So an individual permit to go to sanitary, and then if you have an individual permit to go to surface water, that's going to be your most stringent application process and your most stringent permit. It'll have the lowest limits, and it'll just have the most terms. It would likely be toxicity monitoring. So in theory, if you can avoid doing this one, that would always be the preference. So what goes into the application? So the general permit, it varies based on what permit it is, again, what state you're in, but they're usually pretty streamlined. If this list is more geared towards an individual permit application. So you have your facility and your process information. So you're going to be required to submit that water balance, those process flow diagrams, your chemical inventory, and then site plans and floor plans, so your facility drawings. Your wastewater treatment system, if you need one. So they'll want your piping and instrumentation diagram, your specification and cut sheets on your system, your O&M plan, any pollution prevention plans that are required. There's almost always a spill prevention and control plan, which is different than an SPCC because it'll address just chemical use in your facility and how you're going to make sure it doesn't, you know, go out into your wastewater. A TOMP, which is a toxic organic management plan. So that's also more geared towards a 40 CFR 433 metal finishing facility. A slug control plan, those are for POTWs. So the POTW wants to know that you're not going to send a whole bunch of stuff to the, you know, at once that's going to overcome your treatment system or cause an issue at the POTW. So they generally ask you to develop a plan to ensure that that won't happen. And then most applications do require certification by a professional engineer. So really important to remember, the things that are in your application become part of your approval. So even though this stuff isn't attached to your application, isn't attached to your permit, it was in your application, and your permit assumes that everything in your application is true, valid, and current. So if down the road something changes, you generally need to modify your permit to account for that change. So wastewater treatment. Well, I guess, is there any other questions on this section? No. So treatment systems. So most process effluent sources will need to be treated to some extent to meet the effluent limitations. Treatment systems can be end of pipe or closer to the point of generation. So another really important thing to remember, even if you've decided to close loop your process and not discharge the water, you still need a permit. Seems really strange. But that is because of this guy, the RCRA wastewater treatment unit exemption. So by having a Clean Water Act permit and covering your treatment system and its tanks and holding and conveyance and everything, you do not need a permit under RCRA if your wastewater is hazardous. You are not treating hazardous waste, even though technically you are. So in the case where your wastewater would be hazardous and you are treating it to below haz levels, you don't need to be a TSDF to do that. Having a Clean Water Act permit exempts you from being a TSDF. So this is one of the biggest benefits to having a Clean Water Act permit, particularly when you have a closed loop system. If you have a closed loop treatment system and it's treating hazardous waste and generating hazardous waste usually as well, you're treating hazardous waste. You would need a RCRA permit, but you cover the closed loop system, even though it's not being discharged, you can still cover your closed loop system under a Clean Water Act permit. Florida actually has one of the nicest ways. Not all states do it as streamlined. Florida has a specific provision that says, here it is. Here is an application for a closed loop system. And most of the POTWs issue closed loop system permits. In some states, you still get a permit with limits, which seems silly because you're not discharging anything, but Florida actually does a really nice job of this. So for a new facility or process, there's often this challenge. Which came first, the process or the system to treat it? So we get into these situations where, someone will come to me and say, hey, I want to make this thing. We're going to do this thing. I need a treatment system. I need a permit. What do we have to do? I'm like, okay, well, what is the thing going to generate? Well, we can figure it out on paper and we can go through the process I described earlier, understanding, what you're making. But then we get to the point where we have to then create a treatment system, do some design work. We don't have any water. So we get into the which came first, the chicken or the egg scenario. So being able, this is where, to the question earlier about who does what and facilities versus process versus EHS, you really need to work as a team on these things because you start needing to rely on your process engineers a lot for this part. Most of the time, the process engineers will have already done some bench scale testing, will have already tried to do this thing somewhere, and we can replicate full scale conditions by using whatever bench scale tests that they've done. And we're generally able to project forward in permitting and in treatment system design based on some bench scale process. So make friends with your process engineers because they often hold the secrets to the whole thing. So understanding your system, your P&ID and your operation and maintenance plan become part of your approval. So make sure both are accurate. This is a pretty common thing where an application will go in with a design like this on it. And then halfway through the construction process, something changes, something gets moved, something gets modified, new drawings never go into the department, and you're operating a system that's different from that which you were authorized to operate. So this is where that my line earlier about your application becomes your authorization, right? If it's in your application, it essentially is in your permit. Making sure that everything is correct, it's ground truth that you have as-built conditions. And then review that O&M plan in detail. Understand what records you need to keep and make sure that the process actually works. I was auditing a facility in Miami, actually, and they had an O&M plan that was about yay thick. And it had forms. So many forms. So many forms. So I'm doing an audit, making sure they have everything they need. And I'm like, you have not filled out any of these forms. Maybe half the forms are filled out. And they're like, well, it's just not necessary. There's too many forms. It'll take me 3 hours a day to fill out all these forms. And the operator said, I fill out what's important, what I need, it needs to be done to track how my system is operating. We have all these things. So, we looked at it and we're like, all right, if you're not going to fill them out and they're not a regulatory requirement and you don't need them, then let's take them out of your O&M plan and revise it. We want to always make sure that in your application, you're submitting what you really can do, right? Do as you say you're going to do. If it's in your O&M plan, you need to be doing it. So make sure what the equipment manufacturer or whomever wrote your O&M plan wrote, it's actual practical in practice. Right down to how to check your probe. If you can't reach the probe at the top of the tank without, doing practically a confined space entry, then maybe it's not practical to do that every day, right? Make sure what is written is able to be done. Questions on that one? Okay, so the not fun part, violations. So some common violations, right? Exceedance of effluent limitations. That's what everyone thinks of as a violation of a wastewater permit. But there's a lot of other ones too. So improper sample collection, preservation, handling, analytical. The actual analytical method that's used often causes a violation because maybe it's not the right one. If it's not in 40 CFR 136 and it's not approved for wastewater, then it can't be used. So I've seen clients, getting issues with that. Not maintaining complete monitoring records or DMRs, right? So this is where, again, in your O&M plan, if you're supposed to keep something, you got to keep it. If you're not going to or it's not practical, then let's write it out. Discharging without a permit. So having sources that aren't covered under your permit. Maybe you added something, maybe you missed something, but discharging without a permit is a major issue. Submitting a late permit application. That one can wreak havoc because in some cases, if your permit expires, you're out of luck. You have to stop discharging. And then improper operation and maintenance of monitoring equipment and alarms. So most of those violations really stem from a few primary issues. Poor operation and maintenance, not understanding what you have, not keeping the right records, or implementing a formal record-keeping program. And did I mention operation and maintenance? The operation and maintenance issues, equipment issues, are the number one cause of system upsets, of exceedances, of all violations, I think, usually stem from an O&M problem. Maybe your infrastructure or your treatment system is just aging. Maybe probes are acting up. pH probes are frustrating little devices. Sometimes they get, very picky. They don't want to do what they need to do. So operation, you need to be doing, regular checks, regular calibration, regular cleaning. So a lot of times when violations happen, particularly in terms of pH, the first thing we ask was the violation real? Did it really happen? Or was it just a probe drifting and getting wonky because it hadn't been cleaned or calibrated in a while? So similar to the permitting process, there's a few things you must determine if you've had an issue. What did you violate? How long did it happen? And how much? Quantifying your violation. How many gallons of water, right? How much over a effluent limitation did you discharge? And then determining your root cause, because you always have to report why did it happen, to the agency. And most often it's O&M. So I know we're coming up on the end of the time, but really quickly. So what do you do if you do get an NOV? So I consider it the 3 R's, right? First R being receive it. Read every page, note your timelines or any discrepancies. There are occasions where an inspector might not have understood something and cited you for something that wasn't real. So make sure that everything that's in your NOV is true. Understand how serious the violation is. Should you get internal, external counsel involved, determine, based on how serious it is, and then who's going to be leading the response. The second R is respond. Conduct a thorough investigation, validate that each of those issues actually occurred, determine your cause of your issue. Is there something obvious, some low-hanging fruit you can fix before that first 30-day deadline comes for response? Set realistic timelines. Sometimes you can't fix everything within your response window. If you need that extension, ask early and set a schedule. And then always allow enough time for comprehensive review by all parties. The third R is reconcile. So make sure your timelines are being met, update your schedule regularly, stay in communication with your regulator, address issues as they arise, and then track completion of each of the items with the timelines established. Your last letter to the agency should essentially be a check that this is what you said we did, this is what we did to fix it, this is when it was done, we're good. And then always ask for proof of closeout. Sometimes NOVs have the tendency to linger on the record for a while. Always make sure that they've been closed and you get your letter that says, yep, we like what you've done, good to go. If you do find that you've done something and you find it yourself during the course of an audit, there is an EPA audit policy that will essentially allow you to avoid some penalties associated with those violations if you come clean on your own. And that is all.
Thank you, Danielle. Do we have any questions in addition to any that were already asked? You can see Danielle Sandella from Langen Engineering. Maybe it was so comprehensive that they, they got everything they need.
Everybody has everything.
All right, folks, let me stop this recording. Oh, here we go. Okay.
Welcome.
Okay. So if you have any questions to follow up, please email me, let me know. My email was on the invitation and I can surely get them to Danielle. And then we are recording this today and we will put this in the video library on our website so you can review it again. Thank you everybody for your time today and I hope you have a good weekend.
Thank you. You too.
Hi, everyone. Thank you.